Hello everyone. Let's wait for a few more minutes for others to join, then we will start. Okay.
Okay, ma'am.
Let's start now. Okay, so this is your week 10 doubt session. You can start asking your doubt. I'll start with the activity questions.
Yes, ma'am, you can start with the activity questions.
Yeah. So this is the first activity for week 10. Anyone has any doubt in this activity? Any question you want to ask from this? Have you tried solving the question?
Yeah, ma'am.
Okay.
Yes, ma'am.
Okay, you have any doubt? Any question? Okay, from 10.3. From this activity? No one has any doubt?
Ma'am, the fifth one.
Question number 5.
Yes, ma'am.
Okay. Okay, so the question number 5 is, in a biased coin, the probability of getting tails is 0.3. Okay. So if a coin is tossed 7 times, then what is the total expected number of heads? Okay. So coin is biased, probability of tails is 0.7. So what will be probability for head?
0.7.
Yeah, one. Yeah, so probability for heads will be 0.7. Okay, so now it is said that the coin is tossed 7 times. Okay, so you can consider it as a Bernoulli random variable. Okay, so suppose x is some Bernoulli random variable. Okay, and the probability for success. Okay, suppose success is for head. Okay, so this is probability of heads. Okay, so this is 0.7. Okay, according to the question. Okay, now what is the expected value for random variable? What will be the expectation here? What is the expectation for Bernoulli random variable?
Summation of x into p of x.
Yeah, that is correct. So what will be the final value? So expectation for Bernoulli random variable is always equal to the p, which is probability of success. You can solve it. Okay. So Bernoulli, which means it is taking two values, 0 and 1. Okay. So if coming head is the success for us, so this is the probability. This probability is 0.7. Okay. And tail probability is 0.3. Okay. Now you can calculate the expected value. It will be 0.7. Okay. So this is for one toss. Okay. Now we are asked to find that the coin is tossed 7 times and we have to tell the total expected number of heads. Okay. So this is for one toss. So you can assume it as xi. Okay. Now we have 7 tosses. Okay. So what we have to do, actually, we have to add all the probabilities for 7 different tosses. Expectation of x1 plus expectation of x2 plus expectation of x3. Okay. Like this, we have to add for the 7 tosses. Okay. So this will be equal to what? 0.7 into 7. Okay. So this will be equal to 4.9. Okay. Is it clear to you?
Yes, ma'am.
Okay. So this expectation of x1 is the expected number of heads in the one toss. Okay. So we are tossing it for 7 times. So we have to add these expectations for all the 7 tosses. In this way, it will be 0.7 into 7, which is 4.9. You can just check the answer. Yeah, it's correct, 4.9. Okay. Any other question from this activity?
Third one.
Third question. Okay. Yeah, so this third question is, in a software office, there are 20 junior developers, of which 8 are men and 12 are women. If 5 junior developers are to be promoted to senior level, what is the expected number of women in the promoted developers? Okay. So in total, we have 20, okay, out of which 8 are men, 12 are women. Okay. And then 5 junior developers are to be promoted. Okay. So out of these 5 to be promoted. Now we have to find the expected number of women in the promoted developers. So actually, this question is based on hypergeometric distribution, which you will see in the next week, week 11. So if I tell you that, so we have our population, okay, so in which the population size capital N is 20. Okay, in total we have 20 members, okay, 20 developers, out of which we can divide our population in two different categories, which is men and women. Okay, so you can see that how many men are there? 8. How many women are there in total? 12. Now what we are doing, out of these, we are selecting 5 developers which are to be promoted. Okay, so now suppose X is the number of women to be promoted. Okay, what we have to calculate? We have to calculate expectation of X. Is it clear up to this point?
Yeah, ma'am.
What is the scenario?
Yes, ma'am.
So the formula actually is N into M divided by capital N. Okay, don't worry, we'll study it in week 11 in detail. So what is N here? N here is the sample size. So you can see that we are taking 5 developers for promotion. In total, we have 20. Okay. Now what is this M? So M is the number of women. Okay. Number of women which are there in the population. So how many women are there? 12. Okay. So this is the formula for expectation. Now you can just put the values. So N is 5. Small n, sample size is 5. Total number of women in the population is 12. Okay. And then we have total population size 20. Okay. So this value will be the, so this will be 60 divided by 20, which will be equal to 3. This is the answer. Okay. Or if you want to understand how this formula is made, you can just see that what is the probability of selecting a woman here.
Ma'am,
You have
12C1 divided by
12C5.
20C1.
12C5 by 12C.
Yeah, so it will be like if you have to select one woman out of the 20, it will be 12 by 20, right?
Yeah, ma'am.
Okay.
Yes, ma'am.
Similarly, you have to do for the 5, like 5 you have to select. Okay. So this is how this formula is made. Okay, don't worry. This is based on the hypergeometric distribution, which you will see in the week 11. Okay. So after studying that, you just come back to this question again. Okay, then this question will be more easy for you.
Ma'am, for now, without this formula, can we do like the previous what we learned, that calculating the probability like 12C5 divided by 20 like 20C5 like that?
That will only give you the probability, not the expected value. Okay.
Like from that probability, we cannot bring the expectation, right?
Uh, Sorry, what? Like I don't understand.
Ma'am, when we have calculated that probability, we cannot
Hmm.
bring this expectation from that probability.
Okay. Okay, 1 minute. So as you can see the formula, what I told you here is that if you have to select a woman here, just consider this situation. Okay, in total we have 20 people, out of which 8 are men and 12 are women. Okay, so you have to do it. Okay, you have to select a woman. Okay, so what is the probability of selecting a woman? It will be 12 divided by 20, right?
Yeah, ma'am.
Okay, and then you have to do it like for 5 times. You have to do it for the 5, like you can see the question that 5 junior developers are to be promoted. Okay, so when you multiply it with 5, okay, you have, this is the probability. When you multiply it with 5, that will give you the expected number of women which will be promoted, which can be promoted.
Okay, ma'am. Yeah.
So now you can relate it with this formula.
Okay. Now got it, ma'am. Thank you.
Yeah,
Probability of the woman will be 12 by 20 or 5 by 12.
it is 12 by 20.
Okay,
If you have to select one woman out of the 20.
okay, got it.
Okay. Okay, any other question from here?
No, ma'am.
Ma'am, question number 18 of practice assignment.
Okay, I'll take that also. Any other question from the activity questions?
Hmm.
10.4.
Sorry.
Ma'am, in activity 10.4, the third one.
Okay. Third question. Okay, so you have to select which of the following statements are true. So variance of a random variable can be negative. So what do you think? It should be correct or not?
It should not be
No,
correct.
ma'am.
Yeah, so variance is always a positive number. Okay, it is never negative. Okay, so variance can never be negative. Variance of a random variable can be negative. So this statement will be wrong here. Okay, it cannot be negative. Next is, if the variance of a random variable is 0, then the cardinality of the range of a random variable is 1. Okay, now just understand the meaning of this sentence. So it is saying that variance of a random variable is 0. Okay, so variance is 0, which means there is no variation in the value of that random variable. Okay, it is taking some fixed value. Okay, then it is saying that the cardinality of the range of random variable is 1. Okay, so how is it true? You can see that suppose x is some random variable which is taking value, suppose b, some constant. So it is a fixed value. Now you have to calculate variance of x, which is what? Variance of b. Okay, so there is no variation in the value of x. It is a fixed value. Okay, so the variance of a constant is 0. Okay, now this thing is given. Okay, now just read it vice versa, that variance is 0. Okay, which means that x is having some, it is taking some fixed value. Okay, so there is only one value. We can say that cardinality is 1. Okay, it is taking only one value. This point is clear?
Yes.
Yes. Okay. Then the next is, as the n, size n of the uniform random distribution increases, variance increases. So what is the formula for a variance of uniform distribution? In discrete case, it is n square minus 1 divided by 12. Okay, you can just take uniform random variable. Okay, you can take uniform distribution, you can calculate the variance of x. Okay, now in this formula, okay, you can see if you increase the value of n, this entire value will also increase. Okay,
Hmm.
so
How
this
is it n square minus 1 by 12?
okay, this thing you can calculate by using PMF. Okay, suppose it is 1, x is some variable, which is uniform, so it is taking values 1, 2, 3, 4, like up to n, and the probability will be 1 by n for each value. Okay, now you can calculate the variance. What we have to calculate? First, you have to calculate expected value of x. Okay, and you have to calculate expectation of x square. Then you can just use this formula. Okay, by using this formula, you will get this value. Okay, variance of x, variance of Bernoulli, discrete uniform random variable. Okay, you can just solve, you will get
Okay,
this
ma'am.
value. Now from here you can see if you
Ma'am,
increase the value of x.
ma'am, same formula use question number 5, right? Activity 10.4. Same formula use n square
Uh,
minus 1 by 12.
Where? Which question?
Question number 5.
What is the variance of random variable whose probability distribution is this? Yes.
Yes, ma'am.
You can use it here. Okay. If you remember the formula, you can directly use. Otherwise, you have to calculate expectation of x square, and then put the value, and you will get the answer.
Okay, ma'am.
Okay. So, yeah, third statement is correct. Now, the last statement is variance of a Bernoulli random variable is maximum when p is equals to 0.5. Okay. Now first we should know what is the variance of Bernoulli random variable. So first of all, suppose x is a variable which is following Bernoulli distribution with parameter p. Okay, p is the probability of success. Okay, again you can find the variance of x Bernoulli random variable x. So if you remember the formula, it is p into 1 minus p. Okay, if you want to verify, you can just find it from here. This is the PMF of Bernoulli random variable. Okay, again, find the expected value, find the expectation of x square. You will get this answer. Okay, now just look at this here. Okay, so we all know that P is the probability of success. Okay, it is a probability. So P always lies between 0 to 1. Yes or no? Okay, now
Yes,
it
ma'am.
is saying that this value will be maximum when it is taking value 0.5. P is 0.5. Okay, so P is 0.5. The value of 1 minus P will also be 0.5. Okay, so the entire value will be 0.25. Okay, now you can take any other value of P. Suppose 0.4. So what will be the variance of x in that case? It is equals to 0.4 into 1 minus 0.4, which is 0.6. So this value will be equal to 0.24. Okay, so now you can see in this way, like when P is 0.5, okay, this value is also 0.5. So this multiplication will give you the maximum value. Okay, you can just take any other value of P. Okay, and you can check what value of variance you are getting. It will always be less than this value. Okay, you can just think of it. It is a fraction. When it is 1 by 2 into 1 by 2, then it will be maximum. Okay, because the formula is made like that. Okay, you can take any other value. Suppose if P is equals to, suppose 0.7. Okay, If you are taking P 0.7, then variance will be P 0.7, 1 minus P, 1 minus 0.7, 0.7 into 0.3, it will be 0.21. Okay. So apart from the value 0.5, it will always be less than this value. Okay, so variance is maximum at P equals to 0.5, which is 1 by 2. Okay, now is it clear?
Ma'am, why are we
Yes.
multiplying variance of x as like p into 1 minus p?
Okay, this is the formula for variance of P. Variance of X. If X is following Bernoulli random variable with parameter P. Okay, I told you that if you want to verify, okay, X is a random variable taking two values 0 and 1. Okay, with probability P and 1 minus P. So how will you calculate variance? First of all, we will find expectation of X. Okay, this is 0 into 1 minus P plus 1 into P. So this is equals to P. Now you have to calculate expectation of X square. This is what? 0 square into 1 minus P. Okay, plus 1 square into P. This is also again P. Okay, now the formula of variance is expectation of X square minus expectation of X whole square. Okay, so just put the values. This is P, this is also P. Okay, so if you take P as common, it will be 1 minus P. Okay, now is it clear?
Okay, ma'am.
Yeah, so in
Yes,
this way you
ma'am.
can find the variance for any distribution. Okay, but it's good to remember the variance and expectation
Yes.
formula for the standard distributions like uniform, Bernoulli. Okay, in the upcoming weeks, you will study a Poisson distribution, exponential distribution. Okay,
Yes, ma'am.
you can just match the
Ma'am,
answer.
in 10.5 activity.
Hmm. Yes, 10.5.
Ma'am, third question.
Third question. Okay, the variance of number of tickets sold in a day in an opera theater is 25. Okay, I will write it mathematically. Suppose X is a random variable which is representing number of tickets sold in a day. Okay, number of tickets sold in a day. Okay, in opera theater. Okay, so now we are given that the variance of the number of tickets sold in a day in an opera theater is 25. So what are we given here? Variance of X. Variance of X is given as 25. Is that correct?
Yes, ma'am.
Okay. Now the next line is, if for each ticket sold, the profit is 25. Okay. Then what is the variance of the profit obtained in a day in rupees square? Okay. So first of all, it is saying that for each ticket sold, the profit obtained is 25 rupees. Okay. Which means like for one ticket, so profit for one ticket is this is equals to 25 rupees. Okay. So what will be the profit for X number of tickets?
25x.
25x. Okay. So for one ticket, the profit is 25. So for X number of tickets, it will be 25 into X. Okay. Next is, we have to find variance of the profit obtained in a day in a rupee square. Okay. So can you tell me what we have to find? Variance of what we have to find here?
Variance.
yeah, we have to find variance of, you can just read this line again, variance of profit obtained in a day. Okay. And in one day, okay, we have suppose uh, in a one day, number of tickets sold is X. Okay. So the profit is 25X. So we have to find the variance of profit, which is 25X. Okay, now is it being clear? We have to find the variance of 25X, variance of profit. I will write it
Yes, ma'am.
again clearly. Okay, variance of profit. Okay, so now profit in one day is 25X. So variance of 25X is something we have to calculate. Okay, this is X, not the multiplication sign. Now this is 25 square and variance of X. Okay, so this will be 25 square and variance of X is also 25. Okay, so this will be 25 whole cube. Okay, now is it clear to everyone? So you just
Yes,
calculate
ma'am.
this value. This is equal to 15,625. Okay.
Yes, ma'am.
Yes. Any other question from this activity?
No, ma'am.
From any other activity 10.6?
No.
Explain a little bit about extra activity 4. The PMF that is understandable, but the second part is in the sample. In the second part, it is a little hard to know that what need to be done.
Okay, this is something you have to put efforts on. Okay, so instructions for doing extra activity is all there on the portal. You can find that. Okay. If you have any doubt regarding extra activity, you can discuss it in the TA sessions. Okay. If you have any
Ma'am, in that
conceptual
activity,
doubt here,
ma'am, like
yeah,
how to find
activity.
out the binomial distribution?
Okay, binomial distribution is there in week 11. So binomial distribution is actually the summation of Bernoulli random variable.
Okay, ma'am. Like, is there a formula to calculate it?
Hello, am I audible now?
Yes, ma'am.
Yeah, actually I got disconnected because of the network issue. Just give me a minute. Yeah, and now is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, just a minute. Yes, so we were discussing about the Bernoulli and binomial distributions. Okay, so for a Bernoulli distribution, you have studied that if you're tossing a coin, suppose, okay, let's take this example, you have two outcomes, head and tail, right? So this is the example of Bernoulli, okay, where we have two kind of outcomes. Okay, so when you are tossing a coin only one time, single time, okay, then it is a Bernoulli random variable, okay, Bernoulli with parameter p. But if you're repeating this trial, okay, suppose if you're uh, tossing a coin, suppose n number of times, suppose n is equals to 10, okay, then it becomes binomial, okay. So actually it is the summation of 10 Bernoulli random variables. Okay, as you we solved one question.
Can you repeat? I'm able to understand that.
Okay, I'll repeat. We solved one question that was actually based on binomial. Someone asked this question.
What is
Yeah,
this?
this question you can see. Okay, so this you can see I did the summation. Okay, so that summation actually tends you towards binomial. Okay, here you can see that in a biased coin, the probability of getting tail is 0.3. Now we were tossing the coin 7 times. Okay, so you could just see the solution. Okay, this question, you can see that we did the summation of these Bernoulli random variables. Okay, so summation of Bernoulli becomes binomial. Okay, so in Bernoulli we have only one trial. Okay, but in binomial we have n number of trials. Okay, this n is a finite number. Okay, so there is a PMF of it. You will study it in the next week, week 11. Okay, then I will explain it to you. Okay, so the expectation of this binomial random variable, okay, binomial n comma p, this is np. Okay, because if you remember that expectation for Bernoulli, if X is Bernoulli P, then expectation is P only. Okay. But if you are talking about the binomial, okay, we have n number of trials. So we have to multiply it with P. Sorry, we have to multiply it with n. Okay, and this is the PMF for binomial. Okay, so don't worry about this as of now. This you will study in the next week content. Okay. Is it clear to you?
Yes, ma'am, clear. Actually, this
Yes,
calculation is in the activity 4, which is going. The last date of submission is 3rd of December, so that's why actually have to know.
Yes. Okay, if you have any conceptual doubt, then that I can clear, but okay, otherwise sample solution is also there. You can check that. Okay, if you want to ask any conceptual thing, that I will clear. Okay. Okay, so this is like Bernoulli is kind of a special case of binomial. Okay, when this n is equals to 1, then the binomial distribution is Bernoulli. Okay, so in Bernoulli, you have to perform a trial, you have to perform a experiment one time only. Okay, you have one trial. If you have n number of trials, then it is a binomial random variable. Okay, binomial distribution. Okay.
Ma'am, I have a question.
Question. Yeah.
So like in the example that was given for the extractivity 4, when we scroll down, we are given a map, like a graph. So in that, like we have like one graph of like one line of binary and another one for experimental. So what's that?
Okay, I don't remember it actually. I need to check it. Okay, so you can discuss extra activity things in the TA sessions. Okay.
Okay.
Okay, any other question from week 10?
ma'am, practice assignment question.
Okay.
Ma'am, question number 18. Can you please explain that?
Okay.
Yes, ma'am.
Okay, so yeah, so did you check the solution first? It's already given. Okay. For practice assignment, we provide solutions also.
Ma'am, practice assignment, I have one doubt.
Okay, we'll take that.
Okay.
Yeah. So the question is, I will explain from the given solution. So the question is the cumulative distribution function, okay, CDF, for a discrete random variable is given below. So this is the CDF given to us. The next is, if probability X is less than or equal to 2, okay, this is equals to 0.7. Okay, and probability X is greater than or equal to 2 is 0.75. Okay, so we have to find the expected value of X. So basically this information is given us so that we can find the value of these constant A, B, C. Okay, and then we can find the expected values. Okay, so you can see that the first line is here given. This we have written this thing, this information. Okay, now you can see that probability of X is less than or equal to 2 is 0.7. This is given. Now we can find it from the given CDF also. Okay, so you have to write the value of this thing from the given CDF. Okay, so you can see that X is less than or equal to 2. In the given CDF also, you can see that this line, 1, 2, 3, fourth line is X is equal to 2. Okay, so this value actually 0.15 plus A plus B. This is the value of CDF of X at 0.2. Okay, first of all, do you all know what is CDF?
Yes, ma'am.
CDF is the cumulative distribution function and how we define it. So it is defined as fx, okay? So this is probability that capital X is some random variable which is less than or equal to some value, suppose small n, okay? Now, this is CDF at point 2, okay? So this is probability X is less than or equal to 2, okay? So now in the question it is given that the CDF, okay, when X is equal to 2, you can see this equality sign here, okay? So this value is 0.15 plus A plus B. So this is this is something we have written from the question. Okay. Now from here you can form this equation. A plus B will be equal to 0.55. Okay, you can just solve this. I hope up to this point it will be clear.
Yes, ma'am.
Okay. Next is we are given probability X is greater than 2. Greater than or equal to 2. So this value is 0.75. Okay. Now we can also write this from the given PDF. Okay. So tell me, how will you write it? Okay, just tell me. It is also written here. How will you find this value?
X less than equal to 2,
Or
ma'am?
n is greater than.
Less than 2.
It is actually 1 minus probability X is less than 2.
Yes, ma'am.
Okay. So X is less than 2, which means up to this point. Okay. So this is what? 0.15 plus A. Okay. You can see that when X is less than 2, this value is, the CDF at this point is 0.15 plus A.
Excuse me,
Is
ma'am.
okay.
Ma'am,
So we
when
have,
we taking value less than 2, so we don't have to include the upper values like 0.15 and all that. They're also less than 2.
you see, there is two things. So first of all, it is a discrete random variable. Okay. So the first in this line you can see it is okay. So the values of CDF, okay, these are given. Okay, values are given. Now, how will you decide the value? So you can see there is a equality sign at 2. Okay, so when X is between 2 and 3 and also it is equal to 2, then this is the value of CDF, which is 0.15 plus A plus B. 0.15 plus A plus B. And this value is 0.15 plus A. Okay. Okay. So probability X is less than 2. This will be equal to, this will come in this line. Okay. X is less than 2. So this will be the probability. 0.15 plus A. When we are taking it at point 2, okay, when you are including this point, X is less than or equal to 2, okay, that is given as this value. So this is 0.15 plus A plus B, okay. Now, probability X is greater than or equal to 2. This is something we can write as 1 minus probability X less than 2. Is it clear up to this point?
Ma'am,
Yes,
why
ma'am.
not less than or equal to 2? Because
Okay.
it's just
Yeah, because it's a discrete random variable. So probability at X is equal to 2 is already here. So it's like if I draw the
oh, okay. From the inclusion, you are subtracting that part. I understood.
yes. Okay, this is suppose 0, 1, 2, 3. So greater than or equal to 2, which means up to this point to all like everything which is greater than 2. Okay. So from the entire, we will reduce which is less than 2, which is below 2. Okay. So 2 is already included here.
Okay,
Okay.
ma'am. Yes.
If suppose we are written x is greater than 2 only, then you can write it as 1 minus probability x is less than or equal to 2.
Yes,
Okay.
ma'am. Yeah,
So
got
because
it, ma'am.
here x is a discrete random variable. Okay. When you study about the continuous random variable that will come in week 12, then you will see that this inequality sign does not matter, because for continuous random variable, the probability at a single point is 0. Okay.
Okay,
That
ma'am.
will come in week 12, continuous random variable. So this you can write as x greater than 2 plus x equals to 2. Okay. So for continuous random variable, probability at a single point becomes 0. So in that case, that equality sign, okay, whether you write greater than or equal to, or you write only equal to, the both will be same. Okay. That
Okay,
is for
ma'am.
continuous random variable, not for discrete. Okay. For discrete, you have to take care of these signs. Okay.
Got it,
So
ma'am.
now, yeah. So now we have, yeah, from here you will get the value of A. Now we have these two equations. We got both the values of A and B. Okay. Okay, we got the values of A and B. Then F4. Okay, now from the CDF, yeah. Now from the CDF, you can see that the value at point 4, the value of CDF at point 4, what is that? This one, last value.
1.
Okay, and we all know that at the last point, the CDF value is 1. Okay, here you can see that random variable is taking values 0, 1, 2, 3, and 4. Okay, it is going 0, 1, 2, 3, and 4. So this is the last point. So at the last point, the probability will be 1. Okay, area under the cover will be 1. Okay, so that's how we can write this equation. Okay, that 0.15 plus A plus B plus C plus 0.15 is equal to 1. Okay, from here you will get the value of C. Okay, so now we have calculated the values of all the constants A, B, and C. Okay, now you can just put this value. Okay, up to this point, is it clear to everyone?
Yes,
Yeah,
ma'am.
ma'am.
If you have any doubt, then I will explain again to this point. Anyone?
No, ma'am.
Okay, so up to this point, I hope it's clear to everyone. So now we are having the CDF. We have to calculate the expected value. So we need what? We need the PMF, right? We need probability mass function. And here we have calculated the CDF. Okay, so what we have to do? We have to calculate the probabilities for each value. Okay, so you can see that in this question, we have 4 points. 0, 1, 2, 3, and 4. Okay, we know the CDF. By using the CDF, you can find the value of PMF. Okay, you can calculate the value for each point. Okay, so suppose you are given CDF at point 1. Okay, so this will be okay. Similarly, you can write that CDF at point 0. So this will be equal to what? Probability x is less than or equal to 0, which is what? Probability x is equals to 0 plus probability x is less than 0. So what is probability x less than 0?
0.
This is 0. So the CDF at 1 is equal to what? Probability of x equals to 0. Okay. So you just have to use these formulas and you can find the value of probability at each point. Okay. So now you can just see here. Okay. X less than 0 is 0. Okay, so CDF value at 0 will be 0.15. Okay, you can just see the CDF here. Okay, so the probability at 0 is 0.15. Okay, now similarly, what will be CDF for CDF at 1? CDF at 1 is 0.25. Okay, now what is CDF at 1? It is the summation of probabilities at 0 and 1. Okay, probability at 0 is 0.15. Okay, I'll write it again here. CDF at 1. What is this? Probability x is less than or equal to 1. So this we can write it as x equals to 0 plus x equals to 1. Okay. Now probability x equals to 0. This we calculated here. We can just put this value. So this is 0.15. This is 0.15. Okay. And the CDF at 0.1 is 0.25. Now from here you can find the value of probability at 0.1. Okay. Is that clear? Yes, no? Okay. Now you just have to do it for all the values. Okay. So you have to calculate the probability value for 0, 1, 2, 3, and 4. Okay. Similarly, you can find the probabilities values. And after calculating the probability value, you just have to use the simple formula of expectation. Okay. I hope you can find it.
Yes, ma'am.
Okay. Yeah. Okay. So the main idea of this question is you are given this information. Okay. And you are given the CDF. First of all, we will calculate all the these formulas. Okay, then find it. Once you know, then you usually find the expected value.
Ma'am, your voice is
Now can
breaking.
ask you a question.
My voice is breaking.
Yes, ma'am, your voice is cracking.
Am I audible now?
Yes, ma'am.
Yes, ma'am.
Yeah, ma'am.
Okay. And any other question?
Ma'am, question number 3.
Practice.
Yeah, ma'am. Practice assignment question number 3.
Okay. Yeah. So here, entrepreneurs invested in 4 startups. If the startup made profit, will yield respective profits of 10, 20, 30, and 40 in max. Okay. On the other hand, for each startup, the entrepreneur may not gain profit. He will incur a loss of 3, okay, in units of lakhs. If the probability of the entrepreneur will profit from these startups are respectively these, what is the expected profit? Okay. So what we have to do here, we take
Ma'am, your voice is cracking.
Ma'am, your voice is cracking and screen is frozen.
Yes, ma'am.
Okay, is my screen visible now?
Ma'am, it's loading.
Now is visible?
No, ma'am, actually not visible. Now visible, yeah.
Now visible, ma'am.
Okay. Okay. Yeah. So here you can see that entrepreneur has 4 startups. Okay. So what we have to do, we will calculate the expected profit for each startup first. Okay. And then we have to add the expected profits for each startup. That will give us the total expected profit. Okay. Is the idea clear? What we have to
Yeah,
do in the
ma'am.
question?
Yes,
Okay.
ma'am.
So we have to calculate the expected profit for each startup. Now for this thing, what we need? We need the PMF of that variable X. Okay. So what are we doing that? We are taking that Xi is the variable which is representing the profit. Okay. It will represent the profit of ith startup. Now here we have 4 startups. So value of I will be 1, 2, 3, and 4. Okay. Now go back to the question. We can see it's written here that the startup will have profits of 10, 20, 30, or they may have may not gain profit, or they can have a loss of 3. Okay. So for the first startup, we have profit value as 10, okay, and loss value as 3. Okay, so you can see that for the first startup, okay, okay, so X1 is taking 2 values, 10, okay, and -3. So it is a loss, so we are taking as negative. Is that clear to everyone up to this point?
Yes, ma'am.
Yeah, ma'am.
Actually, there is some network issue happening on my side. Is my screen visible again?
Yes, ma'am, it's visible.
Okay. Yeah. So for the first startup, we have profit of 10 lakhs. Okay. And loss of 3. So this loss we will represent as negatives. Okay. Now, we are also given the probability value. Okay. So you can see that it is written that if the probabilities for the entrepreneur will make profits from the startup are respectively 0.3, 0. Sorry, 0.2, 0.3, 0.4, and 0.1. Okay. So for startup 1,
P of X is this one, right, ma'am?
yes, probability of for X1. Okay, this is 0.2 for profit. So what will be the value for loss? Probability value?
Ma'am, I think 1 minus the entire thing.
Yes, so 1 minus 0.2, which will be 0.8. Okay. So now you can see that this is the PMF for X1. Now you can calculate the expected value of X1. Okay. This is 10 into 0.2 minus 3 into 0.8. Okay, then you can just calculate this value. This will be equal to minus 0.4. Minus 0.4. Okay. Similarly, you can find it for the second startup. Okay. So this is also given. So you can see that the profit for second startup is 20. Okay. This 20 with probability 0.3. So this is 20 with probability 0.3. Okay. And what is the loss for it? So loss is same. It is -3. Now what will be the probability for loss here?
0.7.
0.7. Okay, it will be 0.7. Now you can find expected value of x2. So this will be 20 into 0.3 minus 3 into 0.7. Okay, so it will give you some value. So this is equals to 3.9. Okay, so in this way you can find expected value of x4, x3 and x4. Okay, I hope you can find these two values. The final
Yeah,
thing to
ma'am.
calculate is the total expected profit. Okay, so total expected profit, total expected profit. So that is equal to expectation of x1 plus x2. Okay, you just have to add the 4 values. Okay, that will give you the final answer. Okay, is that clear now?
Yeah, ma'am. Now understand.
Ma'am, 19th question.
Ma'am,
Hmm.
on my portal, it's only showing 7 questions for the practice assignment 10.
Okay, did you refresh and check?
I did, and the questions are like changing every time. But I haven't got any like 18th question. Like I haven't like got any time I refreshed it.
Okay, so okay, you are getting 7 questions only.
Yes, I'm not getting more than 7.
And each time you refresh, they got changed.
Like yeah, they are like shuffled every time.
Okay. Is there anyone else having the same issue?
Yes, ma'am.
Okay. Okay, so you can just post it on the Discourse and you just mention your student mail ID. Okay, we will check from the backend. Okay, what's the issue?
Ma'am, we haven't got access to Discourse. Can we mail to the support team?
Okay, you don't have access. Yeah, okay. If you don't have access, you can support to you can write a mail to the support team.
Actually, they didn't give the
Okay,
student
ma'am.
ID. That's why.
Sorry.
Team didn't send us the student ID yet.
Okay. You all are term students, right? Not
Yes,
qualified.
ma'am. No, we are term students.
And still you're not having student mail ID.
Ma'am,
Okay,
actually, I
so
mailed the support team regarding that, and they said to wait, so they'll send soon.
okay. Okay. If they have replied you to wait, then please wait. They will share you.
Yes, ma'am. But I am not getting more than 7 questions.
Okay,
I'll
okay. That
still
I will
mail them
check.
regarding this too.
Okay. That I will check. Okay. I will check.
Thank you,
Okay,
ma'am.
so question number 19. Okay, so Aditi has a rare disease due to which she has to take injection every third day. The cost of each injection is 20. So let X represent her weekly bill. Find the standard deviation of her weekly bill. Okay. Okay, fine. So the thing here is that she has to take injection on every third day. Okay. And the cost for each injection is given. So we have to find the standard deviation of our weekly bill. Okay, so first of all, like we have decided the pattern in which she can take the injection. Okay, so you can see that in table 6, each row represent a week. Okay, so you can consider the rows as week. You can see that 7 columns are there. Okay, are you getting my point?
Yes, ma'am.
Okay, so it is like representing the 7 days of a week. So like what can be the pattern of taking her the injection? Okay, so suppose she is taking the pill on the first day. Okay, I'll draw this here. So suppose we have 7 days. Okay, so maybe she's taking the pill first injection first day. Then she has to take it on the third day, which will be first, second, third, and then it will be here. Okay, this is just for notation. You can like it is not first. Okay, the next can be she's taking like she's starting from this day of the week. Okay, then what will be the third day? Third day will come here. Okay, as you can see here as well. Okay, and the next can be suppose she's taking like she's starting from here, then it will be third day will be here. Okay, again if you like if you want to draw it for the next thing, if you want to start from the fourth day, okay, then it will come here. So this one is same as this one. Okay, so you can see that these 3 possibilities are there. It is covering like all the days. First, if you start from here, if you start with the second day, if you start with the third day, okay, or if you start with the fourth day, or if you start with the fifth day, or if you start with the sixth day, or if you start with the seventh day. So you can see that these 3 are the different patterns for her to take the injection. Is that thing clear?
Yes, ma'am.
Yeah, ma'am.
Okay, so now this is the pattern. Now you can just like see this thing. Okay, so it will be like we can see that Aditi may take injection either 3 times or 2 times in a week. Okay, you can just see this pattern. In the first pattern, she's taking 3 times in a week. Okay, or she might take it 2 times in a week. Okay, just see this figure again. Okay, this line will be clear. Okay, now we have random variable x, which is representing her weekly bill. Okay, the next can take values 60. Okay, how is 60? If she is taking the bill, she is taking the injection 3 times. Okay, then what will be the weekly bill? 3 into 20. Okay, that will give you the value 60. Okay, or
Yeah,
it
ma'am.
can be, okay, or it can be 2 times. Okay, sorry, 2 days in a week. So which is 2 into 20, which is 40 rupees. Okay, 40 rupees bill, weekly bill. Okay, so we have decided the values of variable x, which is 40 and 60. Now we have to decide the probability value. Okay, so from the figure itself, you can see that these 3 possibilities are there, out of which only one time, like one possibility is there when she is taking the injection 3 times in a 3 days in a week. Okay, and the other 2 possibilities are there when she is taking the injection 2 days in a week. Okay, so now the probabilities will be 2 by 3. Okay, for 40 rupees, like for taking injection 2 days in a week. Okay, and then for 60 it will be 1 by 3. I hope it is clear now.
Yeah, ma'am.
Okay,
Yes,
now what we have to
ma'am.
find, we just have to find the standard deviation of the weekly bill. So already we have calculated the PMF. Simply we have to find expectation of x square. You can find the variance, square root of variance is standard deviation. Okay, is it clear to everyone now?
Yes, ma'am.
Yeah, ma'am.
Yeah, okay. Any other question?
Ma'am, question number 2 also.
Okay, so question number 2 is a six-sided die is biased. The number from 2 to 6 are equally likely to land face up, but number 1 is thrice as likely to land face up as each of the other numbers. Okay, so if a random variable y is the score shown on the uppermost face, calculate the expected value of the random variable y. Okay, so simply like you have a die which is unbiased, which is biased. Okay, so uh, die has numbers 1, 2, 3, 4, 5, and 6. Okay, their probability is given that from 2 to 6 they are equally likely. Okay, so from 2 to 6 they are equally likely, which means we can suppose we can consider it as P. Okay, and then it is given that number 1 is thrice as likely to land face up as each of the other number. So this probability for 1 is thrice of the other values. So this is 3P. Okay, so this is the distribution of y. Okay, y is what? Y is the score shown on the uppermost face. Okay, like you can say the outcome if you throw a die. Okay, and this is the PMF given. Now you just have to use the property of PMF. Okay, this summation should be equal to 1. Okay, 3P plus summation of these these P's. Okay, 1, 2, 3, 4, 5. Okay, 5P. So this is 8P equals to 1, which is the value of P is equals to 1 upon 8. Okay, what we have to calculate here? Expected value of y. So simply you can just find expected value of y. Okay, you just have to use this formula. Okay, already we know the PMF of y. Okay, just put the value of P here, and then you can calculate the expected value. Is it clear to you now?
Yeah, ma'am.
Okay.
Ma'am, like in questions when we are said like thrice of this one or 4 times of this one, then we basically like you did, like you took P and then you did 3P, 4P, like that you and all the steps that is similar. So like that we can approach this type of questions, right?
Yeah, so this information you can see, it is given to let you know about the probability. Okay, so this is something you have to interpret correctly. Okay, that is given to you so that you can get the PMF of y. Okay, once you know the PMF of y, then only you can calculate the expected value of y. Okay, so since it is a biased die, okay, so biased die, which means the probability value for all the faces, okay, for all the 1 to 6 will not be same. Okay, that's why these values are given.
Okay.
Okay, you can just take any like constant. Okay, P or A, B, C, anything you can take. Okay, just to have like maintain the equation that this value should be thrice of this value. Okay, so you
Okay,
have to
ma'am.
like
Got
interpret
it.
from the given information.
Thank you.
Yeah.
Ma'am, 8th question.
Okay. Okay, question is, Rohan and Jyoti work for the same company. Rohan's Diwali bonus is a random variable with a standard deviation 1000. Okay. And if the Jyoti's bonus is 20% of the Rohan's bonus, find a standard deviation of bonus received by Jyoti. Okay. So here, first of all, we have taken a random variable x, okay, which will be representing the Diwali bonus for Rahul. Sorry, Rohan. Okay. So Rohan's Diwali bonus is a random variable which is represented by x here. Now the standard deviation of x, okay, standard deviation of Rohan's Diwali bonus, which will be standard deviation of X. It is given as 1000. Okay, so this is something we have written. Now the next is Jyoti's bonus is 20% of Rohan's bonus. Okay, 20%. So you can see that X is the bonus for Rohan. Okay, X is the bonus for Rohan. Bonus of Rohan. Okay, so 20% of X, which means 0.2x is the bonus for Jyoti. Okay, so what you have to find? You have to find the standard deviation of bonus of Jyoti, which is 0.2x. This is something we have to calculate. Okay, so this you just have to use the property. What will be the standard deviation of 0.2x? Standard deviation of 0.2x. Okay, this is what? Square root of variance of 2x, 0.2x. Okay.
Yeah,
So
ma'am.
variance of 2x is what?
0.2 whole square
0.2 whole
into x.
square. Variance of x. Again, it will be what? 0.2 into standard deviation of x. Standard deviation of x is given to us, which is 1000. Okay. So this value will be 200. Okay, now is it clear? Any doubt?
No, ma'am, it's clear.
Okay. Okay, any other question? Anyone else having any doubt?
Ma'am, when expectation of, say for example, x and y are two random variables given to us, and questions are asked like x for x and y both, variance is also given, and that thing, that probability is also given, and then it's asked expectation of something like linear 3x plus y, 3x plus 4y, something like that. So, ma'am, like there was one formula for solving this. Can you please say that one?
Okay. So you are given two random variables, x and y. Okay.
Yeah,
Now
ma'am.
you are given some linear function of x and y. Suppose 3x plus 4y. You have
Yeah,
to
ma'am.
find the expectation of it.
Yeah,
Okay.
ma'am.
So for expectation, it is simply 3 times expectation of x plus 4 times expectation of y. Okay. So for expectation, you just have to like, the formula is ax plus by. Okay. Where a and b are some constant. So it is simply equal to a times expectation of x plus b times variance of y. Okay. Now suppose you have to find the variance of
Ma'am,
3x.
that will be expectation of y, not variance of y.
Oh yeah, sorry.
The previous.
By mistake
Yes.
I wrote it. Yeah.
Yeah.
It is expectation of y. Yeah. Okay. So now you have to find variance of 3x, suppose. So 3, which means this constant gets squared. Okay. So this will be 3 square times variance of x. Okay. The formula is that variance of ax is equals to a square times variance of x. Okay. Now if you have to find variance of ax plus y, suppose. Okay. And x and y are independent. Okay. So in the stats 1 course, you will get the independent random variables for calculating these kind of variance. Okay. So if
Okay,
they are
ma'am.
independent, this will be equal to a square times variance of x plus variance of y. Okay.
Okay, ma'am.
Or suppose if you have variance of ax plus by, then it will be a square times variance of x plus b square times variance of y. Okay. But just remember the condition that both the variables should be independent.
Okay, ma'am.
Okay.
Got it.
Then only, yeah, they are equal to this. This will be valid.
Okay. Thank you, ma'am.
Yeah. Okay. Any other doubt? Any other question? Any other question from any activity or the practice assignment? Anyone else having any doubt?
No, ma'am.
Okay. No one has any doubt now?
No, ma'am.
Okay, then we can end the class. Okay. Thank you everyone for joining.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.